Okay, we are now on the last oral presentation of the first day. This is Oakland, California. This is a Mission 6 flight experiment.
Good afternoon, everyone. Hi, my name is Jose, and these are my experiment partners.
Kevin Cruz.
And Zaclalia Hernandez.
We are sixth graders from the School Urban Promise Academy in Oakland, California. Next slide, please. Our proposal's experiment question is, can redworms compost in microgravity? The species of redworms we're using are Eosinophytida. We came up with this question because we read an article that was about astronauts leaving food waste in the ISS. So then we thought about worms and their amazing composting ability. So that's how we got to our question. For our experiment, we will send 2 Eosinophytida with food waste to the ISS, and we will look for changes in the soil composition like the pH, nitrogen, and phosphorus. We're looking how microgravity will affect the worms and the soil. This is important because vermin composting could help scientists on the ISS by using worms as a source to save them space by composting the food waste they don't eat. Also, if they can turn the food waste into rich soil, it can be used to plant seeds that could provide oxygen and or food. Next slide, please. What is vermicomposting? Vermicomposting is using worms to turn food waste into rich soil. Before composting, the worms will first eat the food waste. The pH levels can be acidic or basic, which is not good for a plant's growth and can result with not many nutrients. But worms would eat the not good for a plant's growth food waste and would create a casting. This is what worms poop out. Worms casting will have a pH of 7, which is neutral and can have high levels of nutrients. The soil. Well, soil with casting will be mixed thoroughly and have a neutral pH as well as high levels of nutrients. Vermin composting is important for future space missions. I'm going to pass it on to my partner, Kevin. Zaclalia.
We are going to send 2 Eosinophytida in a type 2 FME with water and nutrients to survive. In volume 1, we will include 2 Eosinophytida and some moist soil. In volume 2, we will include 1 crushed eggshells and 3 millimeters of Oakland tap water. Astronauts will unclamp the worms and the eggshells so that the worms can start composting. Next slide, please. In the past couple of weeks, we tested different amounts of water, soil, newspaper, and eggshells to determine the right amounts for worm survival. We will keep them as cold as long as possible so that the worms can hibernate. When worms hibernate, they use up to 25% of their usual amount of oxygen. Worms can breathe through their skin and can get oxygen from the moist soil. This is why providing as much water as possible since they get oxygen from the moist soil. While the experiment is in space, we will run the same experiment on Earth. We will compare the results from space with the results from Earth. Next slide, please.
We will measure our results by using a soil tester. The soil tester will determine how much eggshells and newspaper will compost. We will test it before and after the flight for both ground and microgravity experiment. We will measure the pH by using a pH tester, so we can compare and contrast the ground one and the microgravity experiment. To see if the soil is rich, we will check the nitrogen, potassium, and phosphorus. Next slide, please. Our hypothesis is Eosinophytida will have the same effect on soil composition and pH in microgravity as they do on Earth. One possible outcome is that Eosinophytida will have the same effect in microgravity, proving our hypothesis to be true. This can mean Eosinophytidas can be used on the ISS and by future space travelers for composting soils and create rich soil. If the soil is not compost, the composition does not change. This could mean Eosinophytidas can not survive in microgravity under the condition that we put them in the most space with limited resource. Or it could also mean Eosinophytidas can survive but do not change the soil composition in the same way due to microgravity. We try to create the best conditions for survival so we can test composting, but still haven't tested worm survival in space. Next slide, please. We would like to thank to our many community partners. Thank you to the SSEP for this great opportunity.
Thank you very much.
Any questions for the Oakland team?
Hi, I'm Bianca, and I'm from Berkeley Heights, New Jersey, and I was wondering, why did you choose this type of worm from other types of worms?
We chose Eosinophytida because we have done research that these type of worms have the strongest capacity to compost food waste as fast as it can, because some take longer. Thank you.
My name is Gabe, and I'm from South Carolina. What inspired you to do this project?
What inspired us to do this project was reading books. We got this idea from reading an article, like we said earlier, that was about astronauts having to deal with food waste in the ISS. So we got our idea basically from an article.
Hello, I'm Michelle from Berkeley Heights, New Jersey as well. What made you choose the eggshells?
Because we have done research that eggshells are not solid, not hard material. For instance, food waste that can make the worms slow down on the composting. So crushed eggshells are easier to compost for them.
Just wanted to make a couple of comments here. We are seeing a lot of Mission 5 and Mission 6. The overwhelming number of experiment presentations today are Mission 5 and Mission 6. They've not flown yet. And so we are hoping that all of the teams will recognize that this is your conference and come back next year and present results. That said, every SSEP flight opportunity has a life cycle associated with it. The Mission 5 experiments have now been locked in for quite some time, and we are awaiting launch. But Mission 6 is in that interesting space between locking down their preliminary fluid and solid concentrations and volumes for formal flight safety review at Johnson Space Center's toxicology office. That started just a couple of weeks ago. And now they have the ability to optimize their experiments for spaceflight, continuing to work on experiments on the ground to see what the optimum configuration might be before we must lock in those fluids and solids as the final flight configuration. And Stacy, when is that due now for Mission 6? When are the... So first draft is Friday, July 25th for the final lockdown of the experiments, and we must lock it all down by, what, a week later? The next... August 1st, and at that point we hand it over to NASA so that NASA understands fully what experiment is going to be flown. And then about 3 weeks in advance of launch, they're going to send their flight experiment to Houston for payload integration. I've been saying this to everybody for a long time. This is real space flight. And what you pointed to before was that you are now optimizing your experiment. You're continuing your research over summer break because spaceflight doesn't know about summer breaks, and you are optimizing your experiment, getting ready for flight lockdown, correct? So yes. Wonderful. So let's thank Oakland, California one more time.